So what we have is a triangle within a triangle, and what they are saying is in figure below, QS and PT are parallel. So we can be able to write in that these two lines are parallel lines. And the lengths of QR and PQ in units are as marked. If the perimeter of triangle QRS is 11 units, what is the perimeter of triangle PRT? So QRS has a perimeter of 11. Now we only know the length of this. We do this side. We do not know the length of this side or that side. Jamie, I ask that you put that away, please. So what we need to be able to do here, ladies and gentlemen, is we need to some kind of conceptualize what we are looking at. So the best thing that I would tell you guys to do, especially when you have a figure within a figure or multiple figures, is just to simply redraw the figures. So that's one triangle. That's another triangle. Q, R, S, where that's 3. And then this side, is this long length 6? No, it's 6 plus 3, right, which is 9. And that's P, R, T. So it's very important for you guys to understand that the length of the larger triangle is 3 plus 6. Does that make sense? Yes? OK. The next thing is, let's go ahead and take a look at how does the relationship between the side lengths and a perimeter work out. Now, I would hope that you guys would remember this from your geometry class, but let's say you do not remember how the relationship works at all. All right? So what I would do is try to make things simple. Right? What are some things you know? Well, I can draw a square. And let's say that square has a length of 2, 2, 2, and 2. Right? Yes? Now, this has a length of 2, and the perimeter is the addition of all the sides, which would be 2, 4, 6, 8. So you could say 2 to 8. So the ratio of the side length to the ratio is 2/8, right? Or same with that. Now, let's triple the sides of this rectangle. So if I triple the sides of the rectangle, I have 3, 6. What am I doing? These are all, what am I doing? That's 6, 6, 6, 6. Would everybody agree? I just timed each side by 3. Correct? Now, let's see what the ratio is from the side length to the perimeter. That 6 is to 6, 12, 18, 24. Are these ratios the same thing? Are the ratios the same thing? Is 2/8 the same as 6/24? Yeah, they're both 1/4. So what I want you guys to understand from this is that the ratio between the side lengths and the perimeter are exactly the same. In geometry, you guys learned about similar figures, right? If they have the same ratios, then you can create a proportion. Right? If I said, that is the 2 as the 6, and let's say this length was 4. Let's pretend we have a rectangle or something like that. If I said these were similar figures, and I say 2 is to 6 as x is to 12, you guys could create a proportion for this, right? Yes? 2 is to 6 as x is to 12. Create a proportion because they're similar figures. The same thing comes with the side lengths and the perimeter. So what I'm saying is they tell us that the perimeter of this smaller figure is 11. So what I can do now, Tyler, is I can create a proportion. 3 is to 9 as the perimeter of the small triangle is to the perimeter of the larger triangle. Because perimeters are proportional to their side lengths. All right? Or as we have here between two figures. So now when we have a proportion, we worked on, where do we work on? We worked on multiplying fractions, right? When you multiply fractions, you multiply across. However, if you have a proportion, meaning a ratio equal to another ratio, that is where we can apply the cross product. Notice there is a big difference between multiplying fractions and solving a proportion. They don't even look anything alike, except that they have two fractions in them. So now I do 3 times x, which is 3x. 9 times 11, which is 99. Divide by 3, divide by 3. X equals 33. OK? FYI,